In today's class, we will have to study about 9709 paper 3. According to the syllabus of paper 3, if we talk, we have the main paper which will be related to our A-level exams over there. Then we will have today to go for the topic of logarithmic and exponential functions. If I talk according to exponential functions, what does it mean? It means that, for example, we are having a function f of x, which we say is equal to y over there. If y is expressed in the form of function in such a way that we have a variable in the exponential of some constant, in the power of some constant over there, then we say it is exponential function. For example, I am taking y is equal to 3 power x, or y is equal to a plus 2 as a constant whole power x, or y is equal to 9 power x plus 2. These all are the exponentials in the power, exponentials in the power, exponentials in the power. These are called exponential functions, exponential functions over there. In case of exponential functions, we also have the representation for logarithmic function. If you just look, the base is 3, the power is x, and variable y is present. If I want to represent my logarithmic function here, then I will say logarithmic function for y equal to a power x can be written as log of what is the base? What is the base of this power? This is a, will be written down. This y will come with the log is equal to x. So I have converted my exponential function of y equal to a power x into logarithmic function in the form of log y. Y was on the other side, log y, and base is being taken from the base of this power over there, and power equated the whole expression over there. Let's suppose he is giving us some example questions over there, which we can write in the form of, let's suppose he is giving log of, represent the or solve the exponential function, which I am taking 10 power x equal to 58. 10 power x equal to 58. If you just observe there, y equal to a power x, I have done the logarithmic expression in this format for this one. Now for this one, what I will say, the base is 10, take it down, and 58 should be coming in the form of y like this, and x is coming on other side, and x is coming on other side over there. And just check on your calculator what is the value of this one. X will equal to 1.76. 1.76. 1.76. It does mean no, there is no detail to go like characteristic and then take the digit number and go for that. Just take only the calculator values. Okay, and if this, here I am talking about the two logs over there. If log has the base 10, then it is called common logarithm. And if log has the base e, then we say it is called natural logarithm over there. And this natural logarithm can also be written as by ln. If it is log x to the base e, I can write ln x over there. If log 10 is to be taken out, it can also be written with only log. No need to write 10 over there. If log is written, it means the hidden base is already present, which is 10 over there. Let's take some numbers to be expressed like, and now I have converted the exponential function to logarithmic function. If he has given some logarithmic function and he is saying solve the exponential form over there and convert it to find the exact value over there. Let's suppose he is saying log of x to the base 10 is equal to 1.88. Let's suppose it has been taken, logarithmic expression is given, and now he is saying calculate this by using exponential format. What you will do? First of all, 10 is the base, 10 power 1.88 will equal to x. I have just written the exponential format of this question over there, in which what I said, x should be coming on the other side. It is taken. This is the base. I have taken it as a base, and I have made this one as a power over there. You can calculate easily 10 power 1.88. Just check on your calculator what is the value over there.
75.8.
75.8. So this is the way how we can interconnect or interchange our common logarithm and our natural logarithm over there. After common logarithm and natural logarithm, we will have also be taken with our smaller values and larger values to be taken out. And why we use logarithm, basically, as you know, like multiplication tables or multiplications of numbers was basically testified with logarithm. There was logarithmic table also available with logarithm and matrices. These were the two methods. So we are studying the first method over there. For example, he is saying here to apply the logarithm to find the unknown variable over there. Let's suppose he is saying that you are provided with the expression of some example to be taken out, log x plus 5, log x plus 5 to the base 3 is equal to 2. If he says find x over there, now I am trying to solve the questions in which format logarithm will go for the questions over there. Find x over there. For logarithmic expression, you will have to find over there. The best way is take this base on other side. This is the base. This power will come upward and you will get x plus 5 over there. Look very carefully. Next one you will have to tell me. So it is x is equal to 3 power 2 is 9 minus 5 is equal to 4 there. So this was the example how to solve the equation given the logarithmic function to convert it into exponential function and get the value of the variable over there. Let's take some other question over there, which he is saying as B part. Like he is saying here that you have log 3x minus 1 to the base should be taken as 2 is equal to 5. How can I write this?
3x minus 1 equals to 2
3x minus 1 is equal to
2 power 5.
Thank you so much. 2 power 5 is 32 plus 1 and 3x, and x is equal to 33 over 3. X is equal to 11 there. So this is the way how we can convert this format over there. Let's take some little bit, I say like complex one over there. Like C is being taken log of 3 under root x to the base x. Yes, how can we simplify this? Let's check over here. Uh, hmm, okay. Now I'm just converting this one into power. I'm not finishing the logarithm from there. I'm writing x log x whole power 1 by 3 to the base x. And in logarithm, there is a rule. If there is a power on the variable, we can take it in the start and we can write it 1 by 3 log x to the base x. If we check here, like we are taking, let's suppose the log in the form of like log, as I told you that the log to the base 10 is also equal to log. If I take log 10 here, then I can write like this. Now I am saying, let's suppose I am taking here log 10. Log 10 there, then the value is 1. Means when 10 10 is written, when 5 5 is written, log 5 to the base 5, then you will getting the value equal to 1 over there. The same case I want to use here, that 1 by 3 into 1 will equal to 1 by 3. This is the way how we can take. On the other end, when I said we can take ln to the base e, or log e to the base e should be taken over there. Then ln e, if you can observe here, ln e, e is equal to also 1. As I have said over there, like log this. Let's suppose I'm taking 5 and 5 is equal to 1 over there. All right. In the same format, I have taken here log x to the base x will make the concept of equal 1 over there. And then we can say ln e log e to the base e will be taken as 1 over there. After this simple basic conversion and introduction of exponential and logarithmic functions over there, now we will have to move towards the laws of logarithm. Laws of logarithm. If we talk about them, for example, we are taking an expression of log. For example, I am taking log x multiply y to the base a is given. You can write, this is our first law. If two numbers are being multiplied by a same log over there, then we can write it log x to the base a plus log b y to the base a over there. Means if it is written log 7 multiply 8, you can write it log 7 plus log 8 over there. This is the example which I have just shown for example formation over there. After that, if two numbers are divided, the second law states that if a number's log x over y is given to the base a, then we can write it log x to the base a minus log y to the base b over there. This is the formation of logarithmic expression to be shown. And let's suppose he is giving log 9 by 11. Then you can write it log 9 minus log 11 over there. This is our second law. In third law, if some expression, the number is being shown x power n, means log to the some variable x to power n, and then I can write it to the base a also. Then I will write it log x to the base a, and this power will come in the start of the logarithm over there, and your expression will become like this. Let's suppose I take here log of, as when I am writing log for numbers, I'm not writing any number like 10 over there, because we already know that the common logarithm is having the base as 10 over there. Log 3 power 4, then it means you can write it 4 log 3 to be shown as a simplified format of the logarithmic function over there. So this was third one was named as power law. Power law. Second one can be named as division law, and the first one can be said as multiplication law. Division law, multiplication law, and everything can be taken into account over there. One thing more, which I will take for these questions after the formulas. These were the basic formulas of the logarithm, which we will apply to find the variable x to solve the linear equations or exponential function equations or logarithmic equations over there. Now he is saying that go for a little bit, take these examples of the laws over there. Let's suppose he is taking log 3 to the base 2 plus log 5 to the base 2. What two logarithms are being added? It means you can convert them when their bases are the same over there. You can convert them into log to the base 2, 3 multiply 5. And if we say he is finding not only the simplified expression, he also asking about the value to be calculated by using this, then we can take here log of 15 to the base 2, and number is 15 over there, then I am saying here is equal to 3.9 over there. But mostly he is just giving the expression over there to be taken into account for this whole purpose. So it is log 15 to the base 2 over there. That was also approximately equal to 3 over there. And for the second law example, he has taken over there log 8 to the base 3 minus log 4 to the base 3 over there. Then we can write it in the format of log to the base 3, 8 divided by 3 there. This is division law, which should be expressed in this format over there. And we can also take in the form of powers over there. This was our second example. According to third example, if I go over there, third example which he has given, he has said that log 2 to the base 5 is also having the power. Let's suppose I'm taking 6 over there plus log 3 to the base 5. Now what to do? First of all, in first step, take this power on above this 2, log 2 to the base 5 to the power 6 plus log 3 to the base 5. Now two logs are being added. Power rule is being already implemented. So you will take log 2 power 6 is 64 plus 3 to the base 5, and it can be remained as it is, or you can add also them by getting the simplified form in the form of a resultant value over there. So these were the little bit questions which I have done one by one as a simple example. Let's go a little bit complex towards it, where he is saying to calculate the value of x over there. Let's suppose he is saying that you will have to go for log of 5, log to the base 5 in the form of expression x under root x divided by 125. He is saying take it equal to log x under root 5. No, example will not execute according to my mind. So again, should be taking as, okay, he is saying log x, just ignore this part. Log x to the base a is being taken equal to 7, and log y to the base a is being taken as 4. Now he is saying calculate the values of, you can calculate the values of log x square under root y to the base a. He is saying calculate this one. I will just implement the laws formulas over there of logarithm. Let's go for x square first, because x square and y both are being multiplied. I'm just applying the addition of logarithm. Log x square to the base a plus log uh, under root y to the base a. As we know, y is having power 1 by 2 and x is having power 2, then 2 will come in the start. Log x to the base a plus log y power 1 by 2, it means 1 by 2 is coming in the start, and it is y to the base a. And you have the values. Log x to the base a is 7, 2 into 7 plus 1 by 2 into 4, and you are getting 14 plus 2, 14 plus 2, which is equal to 16 there. So what I did here in this expression of simplification, these x square and y square were being multiplied. I have applied the law that two variables are being multiplied, then logarithm with the separate variables will be added over there. And then I have arranged the power in the start, and then simplified and tried to balance it according to the logarithm for showing the different given values to be implemented over there. Now, exact question of 3 to 4 marks, or sometimes the 5 marks question over there for the solution of logarithmic equation in your exam. That is mostly first or second question over there. Let's go to be taken as an example over there, where he is saying 2 log to the base 8 into x plus 2 is equal to log 2x plus 19 to the base 8. This is the just example question in which you will be provided, and you will have to find the expression value of x over there. First of all, take log, this power above there, log of x plus 2 whole square to the base 8 is equal to log 2x plus 19 to the base 8 over there. Now, if something is available on both sides, it means if I take anti-log on both sides, then log 8 will be cancelled out, and I will have the expression x plus 2 whole square is equal to 2x plus 19, x square plus 4x plus 4 minus 2x minus 19 is equal to 0, x square plus 2x minus 15 equal to 0. If I go for midterm break over there, x square plus 5x minus 3x minus 15 equals to 0, x into x plus 5 minus 3 into x plus 5 equals to 0, then I will say here it is being shown as x minus 3 into x plus 5 over there equal to 0, and x can equal to 3, x can equal to minus 5 over there. So this is the simple formation of the solution of logarithmic equation. If I take some other example to arrange over there and to try to make the numbers properly over there, he is showing some different type of example here where he is saying 4 log 2 to the base x is being taken with minus log 4 to the base x is equal to 2. Now it means I will have to go for again finding the variable x, but I will have to apply the logarithm in different style over there. Let's suppose I am taking here 4 is being taken above, log 2 power 4 to the base x minus log 4 to the base x is equal to 2. When two logarithms are subtracted, we know they can be written in the form of fraction over there. Then I will write here log 2 power 4 over 4 to the base x is equal to 2. What I am showing to you, when two logarithms are subtracted, then you can write them in the form of fraction over there. Then for this one, I will write it 2 power 4 is 16 divided by 4 log to the base x is equal to 2. From here, this logarithmic function, according to the law, when log x to the base a is equal to y, we can write it a power y is equal to x. Now I can write it x power 2 is equal to 4 1 time 4, 4. So x can be written as plus minus 2. This was the conversion of logarithmic function to exponential function over there. I have converted this logarithmic function into exponential function by making x power 2 over there is equal to 4 over there. So this is the simple format in which you have tried to implement your logarithm for finding the unknown variables over there. He can also give some exponential functions and some other functions related to this. Don't worry if he gives you log in the form of ln. You know that ln is log to the base e, and all the laws of multiplication, division, and power will be implemented in same style. This is your today class. For tomorrow class, we will go with the past papers of this topic of logarithm over there. I have tried to mention here with you. If I give you the quick revision related to it, I simply say exponential function was provided and logarithmic function was provided. Exponential function is when the variable is present in the power of some constant over there. I have given these three examples. Then I took the logarithmic function after conversion of exponential function can also be expressed into a logarithm, and logarithm is used to find the unknown variable over there for the solution of equation over there. Then I told you that there is two type of logarithm: logarithm with common logarithm, that is having the base 10 over there, and natural logarithm which was having the base e over there, that is natural logarithm can also be written as ln over there. And log to the base, if it is written, okay, we can calculate it with the unknown variable. Then the first law was coming, multiplication of numbers was basically testified by using logarithm and matrices. Your multiplication tables were being discussed with the help of logarithm. There were four main laws of logarithm. First law was taken as, these were the little bit examples we have done for you, and the laws were there. Logarithm, two numbers are multiplied, taking the separate log can be added. Two numbers are multiplied, same rule was doing for it. And if two numbers were divided over there, then they can be expressed that logarithm should be subtracted. If logarithm is taken in the form of some power of variable, then power is coming in the start of logarithm number over there. And then try to take the simple exponential examples, and then also solve two exam like questions which will be testified in your final exams over there. All right. Thank you so much for today's class.